There's more to selecting a drive than just grabbing one with a current rating that matches your motor's current rating. Let's walk through this checklist of things to think about when selecting a variable frequency drive. Now, before we get started though, let's make sure everyone understands that variable frequency drives are for controlling three-phase motors. You can't use a VFD with a single-phase motor. If your motor has a starting capacitor and/or a run capacitor, then it's a single-phase motor and you can't use it with a VFD. Of course, you do need to start with making sure the drive can handle your three-phase motor's full load amperage as shown on the motor's faceplate. For example, here's a 1 horsepower general purpose inverter duty motor. Its faceplate says for a 60 Hz supply, it needs 3 amps at 230 volts or 1.5 amps when run at 460 volts. Here's a 20 horsepower farm duty motor. Its faceplate says it needs 46.6 amps when run at 230 volts. And this 2 horsepower washdown motor needs 5.4 amps at 230 volts or 5 amps at 190 volts. So while each motor's faceplate might display it a little differently, they all contain the same amperage information. Okay, given the full load amperage of the motor, we just select a drive to match that, right? No. There are two other things you need to check before selecting the drive. It's important to know what your overload conditions might be. Most drives are designed to handle temporary overload conditions, so when you get that large rush of current when you rapidly accelerate the motor or get a brief impact load, the drive doesn't fault out. Most AC drives are designed to handle around 150% of overloaded current for around 60 seconds, and the ACN drives are no exception. The ACN drives can also handle up to 200% overload for no more than 4 seconds. If your application is going to need to handle more than the drive's rated overload capacity, then you may want to consider selecting a larger drive that can handle the overload conditions to avoid faults and get the performance you need. But be careful. Don't just arbitrarily oversize the drive. Why? Because if the drive gets too big, then it won't be able to adjust the motor protection parameters low enough to keep from burning up the motor. A good rule of thumb to prevent that would be to limit your drive oversizing to around 200% of the motor's full load. If you need more than that, well, it's probably time to rethink your system design. You can also use things like auto torque boost or more advanced controlling methods such as centralist vector or field-oriented control to get the higher torques needed to accelerate the excessive load without overloading the drive or the motor beyond their capacities. One side note, if you're replacing a simple motor starter with a variable frequency drive, then beware. Some motor starters can handle up to 600% overload conditions. If you are replacing a motor starter, then you're probably doing it to soften that instant load anyway. Just don't expect to get the same startup performance with a VFD as you get with a motor starter. Finally, know your application type. Do you have a variable torque requirement like a fan or a pump? Those are usually easier to start and are less demanding. Most other applications are considered constant torque, like machine control, tensioning applications, or conveyors that need to keep things moving regardless of load fall into the constant torque category. If you don't know what your application will be, then assume the more demanding constant torque and make sure your drive can handle that. The good news is the ratings for all ACN drives do assume the more demanding constant torque. Some drives, like the popular Automation Direct GS20 and GS4 families, show both the variable torque and constant torque specs so you know exactly what they can do. So, know what your application is and if the ratings of the drive you select are appropriate for that application. The bottom line is, taking these things into account when selecting a drive will save you a lot of headaches later on and can even extend the life of the drive. Speaking of extending the life of the drive, please be sure to condition, or some folks call it reform, the drive's capacitors before using the drive with a motor. Not doing that shortens the life of your drive and can even damage it outright. Every drive manufacturer has a different procedure. The ACN drives are easy. If the drive has been sitting for more than a year, just apply power for 2 hours with no motor connected. That properly recharges the capacitors so they're ready when the motor demands that first big surge of current. If the capacitors aren't fully charged and the conductive oxide layers inside the capacitors aren't carefully burned off, you run the risk of damaging the capacitors and killing the drive. So if you don't know how long the drive's been sitting on the shelf, go ahead and recharge the capacitors according to the manufacturer's recommended procedure. Well, that ought to be enough to get you started with selecting and prepping a drive. Click here to learn more about the ACN family of variable frequency drives. Click here to learn about Automation Direct's free award-winning support resources, and click here to subscribe to our YouTube channel so you'll be notified when we publish more automation tutorial videos.